Hey everyone, and welcome back to my channel. Or if this is your first time here, a big hello and welcome. I am so glad you have joined me today. In this presentation, we are going to explore the basic structure of database system. We will look at the key parts and how they work together to store and manage our data. Let's dive into the fundamentals of database system architecture. In this slide, we will see the introduction of database. What is database system and the importance of database. First, let's define exactly we mean by a database system. At its core, a database system is structured and organized collections of released data, along with the software that manages and allows access to this data. Think of it as more than just a pile of information. It's a carefully organized digital filing cabinet with a sophisticated system for putting this, finding them, and keeping them secure and consistent. Database management system. This is the crucial software component. It's a intermediary between the users and the database itself. The DBMS as follows as to create and define the database structure, insert and update, delete the data, retrieve information through queries, control access and security, ensures data integrity and consistency. Simple analog. Imagine a library. The books are the data. The way the books are categorized by subject, author, etc., is the organized collection. The librarian and the library's catalog system are like DBMS. They help you find, add, and manage the book effectively. Let we see importance of database architecture. Now that we understand what a database system, let's discuss why is architecture, its internal structure, and how its components are organized and interact is so important. A well-designed database architecture is crucial for several key reasons. First one is efficiency and performance. A good architecture ensures that data can be accessed and proceed quickly and efficiently. This is vital of applications that rely on real-time database retrieval like e-commerce websites or financial systems. A poorly designed architecture can lead to slow queries and bottlenecks. And the next one is scalability. As the amount of data grows and the number of users increases, the database system needs to be able to handle this increased load. A well thought out architecture allows the system to scale effectively, potentially by adding more resources or distributing the data. And the next one is reliability and availability. We need our database system to dependable and accessible when we need them. The architecture plays a key role in implementing features like backups, recovery mechanism, and redundancy to prevent data loss and minimize downtime. And next is components of DBMS. Let's break down the five fundamental components of database management system listed below. Every functional database management system is comprised of several essential components that work together to manage and provide access to data. Let's take a closer look at each of these building blocks. First one is hardware. The hardware component encompasses all the physical electronic devices used to store and access the database, includes servers, storage device, network infrastructure, client machines, etc. Next one is software. The software component is the heart of the DBMS. It's the set of programs and utilities that manage the database environment. This includes the DBMS itself, operating system, network software, application programs, utilities, etc. Next is data. The data component is the most crucial part of any database system. It represents the actual information that the database is designed to store and manage. This includes operational data, metadata, and the data is the valuable asset that the DBMS is designed to organize, protect, and make accessible. And the fourth one is users. The user components refers to the people who interact with the database system in various ways. We can categorize users into different roles. First one is end users, application programs, database administrators. Users are the reason the database system exists. They create access and utilize the data for various purposes. And the fifth one is procedures. The procedure component refers to the set of rules, guidelines, and interaction that grow and the design, use, and maintenance of the database system. These are how to manuals are working with the database. design procedures, operational procedures, maintenance procedures, recovery procedures, security procedures. Procedures ensure that the database system is used and managed in a consistent, secure, and efficient manner. And the next is levels of database architecture. When we talk about the architecture of database system, we often refer to how the different components, the user interface, the application logic, and the database itself are organized and interact. Over time, different architectural models have emerged to address various needs and complexities. Let's look at the three main levels of architecture. First one is one tier architecture. In a one tier architecture, all the components of database system, the user interface, the application logic, and the database itself are all present on the same machine. The user directly interacts with the database on their local system. Characteristics are simplicity, direct interaction, limited scalability. Think of a simple spreadsheet program on your personal computer where you store and manipulate data. The interface you see, the calculation you perform, and the data itself are all on your local machine. Next one is two-tier architecture. The two-tier architecture separate the user interface from the database server. The client applications run on the user's machine and communicate directly with the database server. Characteristics are separation of concerns, improved scalability, client server model. Imagine a desktop application installed on your computer that you use access a company's central database server to view or enter data. The application handle the display and the server manage the data. Next is three-tier architecture. The three-tier architecture introduces an intermediate layer called the application layer between the client and the database server. The client communicates with the application server, which in turn communicates with the database server. Think a web application. Your web browser sends request to a web server, which then interacts with the database server to retrieve or update the information. The web server handles the business logic and acts as an intermediary. In this slide, we see ANSASPARC architecture. The ANSASPARC American National Standard Institute Standards Planning and Requirements Committee architecture is a foundational model for understanding and designing database management system. It processes a three-level view of data, aiming to achieve data independence and better organization. These three levels are external level, the conceptual level, and the internal level. A key principle underlying this architecture is separation of concerns. First one is external level. The external level is the highest level of abstraction and describes how individual users or groups of users see the data. It consists of multiple external views. Each view represents a specific subset of the database that is relevant to a particular user or application. Users at this level are only concerned with the data they need and in the format that is most convenient for them. Key characteristics are user specific, heights complexity, multiple views. Think of different departments in a company accessing the same customer database. The sales department might have a view showing customer names, contact information, and purchase history. The billing department might have a view showing customer names, billing address, and payment details. Both are accessing the same underlying data but see it in a way that's specific to their needs. The next one is conceptual level. It is also known as logic level. The logic level provides a global logic view of entire database. It describes what data is stored in the database and the relationship between the data entities without specifying how the data is physically stored. This level represents the overall structure of the database as seen by the database administrator. The characteristics are global view, data entities, and data types and constraint data independence. Continuing the company database example, the conceptual level would define the entities like customer, product, and order and the relationship between them. Can place multiple orders and order contains multiple products. It would also define the attributes of each entity. The next one is internal level. It is known as physical level. The internal level is the lowest level of abstraction and describes how the data is physically stored on the storage device. It deals with the physical organization of the data, including storage structure, file organization, indexing techniques, and the data comparison method. The characteristics are physical storage details, optimization, data independence. At the internal level, we would specify how the customer table is stored in the disk, the format of the customer ID field, and whether any indexes are created on the specific columns to speed up the searching. And the next is schema and instance. To understand how the database works, it's crucial to distinguish between its schema and its instance. Think of it like a blueprint of building, whereas the actual building itself. Structure definition. The schema of the database is structure definition. It's like the blueprint or the design plan. It describes the organization of the data under the names of the tables, the columns within each table, the data types of those columns, and the relationship between the tables. The schema defines the logical and physical organization of database. Think of a form you need to fill out. The form's layout, the fields it contains, name, address, age, and the type of information expected. Each field, text, numbers are like the schema. It defines what kind of data can be recorded. Next instance, actual data. This instance of database, on other hand, is the actual data stored in the database at the particular point in the time. It's like the data you have filled it into form or the actual contents of the building at the given moment. Using the form analogy, every completed form with specific details filled in the represent instance of the form schema. Similarly, every row in a database table represents an instance of the table schema. Relationship between schema and the instance. The schema provides the framework and rules of the data. You can have the same database structure but different sets of data in the instance. Next, the types of schema: external, conceptual, and internal. We see already that are the types of schema. In this slide, we see the core components of DBMS. A DBMS isn't just a passive container of data, it has several active components working behind the scenes to ensure efficient and reliable data management. First one is query processor. The query processor is responsible for taking user queries in SQL or similar query language and transforming them into a form that the stored manager can understand. It's like the translator and optimizers of DBMS. Next one is storage manager. The storage manager is the component responsible for the physical storage of data in the database and retrieving the data when requested by the query processor. It acts as the interface between the logical and the physical storage device. Next is transaction manager. The transaction manager is crucial for ensuring the database operations are performed reliably and consistently, especially in multi-user environments where multiple transactions might be executing concurrently. A transaction is a logical unit of work that may involve one or more database operations. And next is buffer manager. The buffer manager is responsible for managing the main memory called RAM that the buffer pool or cache. Its primary goal is to reduce the number of expensive disk operations by keeping frequently accessed the memory. Thank you guys.